Hello dear students, in this lecture we are going to start a new topic, that is surface texture and surface roughness. So this is a complete chapter. So in this lecture we will discuss a first part of surface texture and surface roughness. So in this chapter we are going to discuss the following things. First we will discuss that what is the basic understanding of surface roughness, why the surface roughness occurred on the surface, and what is the importance of surface roughness, where surface roughness is necessary in a manufactured part or where it is not necessary. Next, we will discuss about the indication of surface finish on drawing, that how the surface roughness is indicated on the drawing. Next, we will discuss about parameters of surface roughness. What are the different parameters of surface roughness? What are the parameters through which surface roughness of the manufactured product get affected? And later on we will discuss measurement methods for measuring surface roughness. So there are two types of instrument which we use in measurement of surface finish, that is contact type and non-contact type, and we will also discuss about the how the care is taken for these surface measuring instruments. So let's start with the introduction part first. So we know that the engineering components are manufactured by various processes like casting, forging, welding, and after the raw material is prepared by casting and forging, then these components are then subjected to various machining operation for getting required geometrical surfaces. So first of all, we will produce the raw material with the help of casting and forging, and then that raw material is converted into the final finished product with the help of various machining operations. But it is not practically possible to produce a component which is having geometrically ideal surface. Why it is not possible? I have discussed the sources of error. And in the part of limits, fits and tolerance lecture, in that I have told you that there are three components which are responsible for error in manufactured part, that is main, machine and material. So a material cannot be 100% accurate, machine cannot be 100% accurate, operator itself cannot do work with 100% efficiency. So these are also the elements which are responsible for not 100% production of ideal surface. So the surface finish after machining depend upon the material which we use, the vibration in the machinery during the machining process, then deflections, speed, feed, and other condition. We will discuss it later on in detail. The surface finish requirement depend upon the functional requirement of the component to be assembled. Basically, surface finish is required, and it is depend on the functional requirement of the component. For example, in some cases high surface finish is required, and in some cases less surface finish is required. So we will discuss that in which part high finish is required and in which part less surface finish is required. So this is all about the introduction part. Now we will discuss why surface finish. Why surface finish is given to the manufactured part, is necessary for the manufactured part. So surface finish, it is also known as surface texture or surface topography, and it is the nature of surface as defined by characteristics such as lay, surface roughness, and waviness. Let us take an example of engineering component whose surface is open to atmosphere. So that surface contains number of valleys and peaks, and the surface sometimes need to be very rough and sometimes it need to be very smooth according to the application. So for example, if we talk about interference fit, then the surface roughness is of type that the two mating part cannot move with respect to the first part, that it will completely fixed. So in that case, we need more roughness. And if we talk about brakes, if we talk about brakes, so for applying brake, we need a rough surface, because if it is smooth, then brake will never work. So in that case, in case of brakes, we need rough surface. And in some case, for example, guideways of machinery, in that case, we need smooth surface, because one part is to be slided over the other part in the guideways. So it is the need of application that the surface is to be rough or it is to be smooth. It is also improves the look. The surface finish also improves the look. For example, in a car, the body of the car is to be completely finished for having an aesthetic look. A surface finish is also provided to the surface to control the process. For example, in this figure, roughness at each part is different. For example, if we take this surface, the outer surface, extra roughness is provided with the help of knurling process, so that we can hold the workpiece tightly. We can hold the workpiece tightly. So we will have to provide the more roughness. If we talk about this surface, so this surface is obtained by facing process during the turning of shaft at lathe machine. So the structure is like this. So this depends upon the need, that what type of surface roughness is required. It is to be smooth or it is to be more rough. Now we will talk about the importance of surface finish. So surface roughness is important from the point of view of fundamental problems such as friction and wear, surface contact, lubrication, and tightness of joints. I have discussed it in the previous why surface finish is necessary. It also affects the conduction of heat, cleanliness, and reflectivity of the surface. If we see the surface of a car, then it is reflective in nature. Surface roughness is provided to the surfaces which is to be used in heat transfer, because a rough surface can transfer the heat more efficiently. It can also affect the position and accuracy of mating parts, resistance to corrosion. A completely smooth surface is having less corrosion, but more rough surface is having more corrosion. So we have to go according to our need for providing the surface finish. Now, what are the different factors influencing surface finish? The very first factor that influences the surface finish is the machining variable, and the machining variable includes cutting speed, depth of cut, and feed. That what type of feed is given to the workpiece, so that we will obtain the more roughness or less roughness. Amount of depth of cut to be provided for cutting the metals. We have to see that what type of cutting speed is needed to get the required amount of surface roughness. Next, geometry of tool. What type of geometry of tool is required? The nose radius is how much, the clearance is how much, raking angle is how much. Next is workpiece and tool material. What is the nature of workpiece and tool material, and what is about the mechanical properties? So it will also affect the surface finish. Next is quality and type of machine tool used. We have to see the quality and type of machining which we have to do. If we want to do turning, then what type of lathe machine it is. So we have to see that also. Next is lubrication. If a process need lubrication during the machining process, it should be provided there. For example, in knurling process, coolant is required. In knurling process, coolant is required. So to get the required amount of surface finish, so it must be there. We have to apply coolant or lubrication there. If we don't, then we get a very bad surface. Next is vibration between workpiece, cutting tool and machine tool. Vibration is a thing which we cannot neglect or we cannot eliminate 100%. We can reduce it, but we cannot remove completely. So these are the various factors that influence the surface finish. Next topic is classification of geometrical irregularities. So there are number of irregularities on the surface according to which the surface roughness is classified. So the geometrical irregularities can be classified as first order, second order, third order, and fourth order. So we will discuss first order. These irregularities are formed in the machine due to inaccuracies. This irregularity also contains lack of straightness of guideways. This is caused due to metal weight and cutting force. If the guideways of the machinery which is used for machining process is not straight, then the irregularity added in the workpiece due to the lack of straightness of the guideways falls under first order irregularity. Okay. Second is second order irregularity. Irregularity such as chatter marks, that is, are formed due to vibration. This type of irregularity is called as second order irregularity. Any mark on the workpiece formed due to the vibration, presence of vibration, that falls under the category of second order irregularity. Next is third order. This forms due to machining process, even if the machine is perfect and vibration free, are called as third order irregularity. So third order irregularity is due to what? If the machine is free from vibration and there is some irregularity occur on the surface due to tool or due to machining process or due to material itself, then it falls under the category of third order. Next, fourth order irregularity. Fourth order irregularity is the irregularity which occur when the separation of chip during the machining process takes some material from the working surface itself. It is caused due to rupture of material. If you are removing chip from the working surface and some extra material from the working surface come out with a chip, then that type of irregularity falls under the category of fourth order irregularity. Next is type of surface finish. So type of surface finish, first of all we will discuss what is surface. So surface of any body is its boundary which separates it from another body. If there are two body, but this is one body and this is another body. So surface is what? The boundary which separates the other body from it. Generally, there are three types of surfaces. First surface is nominal surface. Nominal surface is what surface? A theoretically geometrical perfect surface is called nominal surface, which ideally exists. It is the ideal surface, like this in this diagram. A surface without having any roughness. So this is the nominal surface. This is the ideal surface, but it does not exist in nature. Next is rough surface. The magnified view of an actual surface as shown in this figure. The surface has numerous small peaks and valleys that deviate from the nominal surface. It is seen that the surface has a certain degree of roughness and it is called a rough surface. Actual surface, when we see in microscope or by the help of any other surface measuring instrument, then the surface look like this. This type of surface comes under the category of rough surface. Next is wavy surface, a surface which is having waviness. Waviness is what? Waviness is the roughness which is present over the surface in the form of wave. Let us suppose this one. So in this wave, the roughness is present over there, but which is having the more roughness width and roughness height. So the waviness is caused by deflection of tools and workpiece, uneven lubrication and vibration. So the roughness produced by these factors falls under the category of rough surface. Okay. Now we will discuss nomenclature of surface texture. So in the nomenclature of surface texture, first is surface roughness. It is the micro irregularities in a surface resulting from the action of production process or that produced during the machining. When we machine a component, then the irregularities present on the surface said to be surface roughness. Next is profile. It is a shape of any section through the surface. Profile means if this is a surface, if this is a component, then the look of the surface of the part is called as profile. Next is flaw. Flaw is what? It is an irregularity that occur in a surface due to cracks, blowholes, scratches. Unless otherwise specified, the effect of flaw should not be accounted in the measurement of roughness, because these are the mostly irregularity which are present during the manufacturing of raw material, for example during the casting process, during the forging process, etc. Next is sample or cutoff length. So the particular length that has to be taken for measurement of the roughness, that what amount of length is to be taken for the measurement of roughness, that length is considered to be the cutoff length, and it is also known as roughness width cutoff, and in most of the cases it is considered to be 8 mm. Next is lay. Lay is what? Lay, it is the direction of the predominant top surface grooves that are produced by machining. Actually, lay is what? Lay will tell you the direction of machining. If this is a surface and tool will move like this, so tool leave its mark on the workpiece, the direction of the machining. So it is called as lay. Next is waviness. These are the surface irregularities that are of greater spacing than roughness. For primary texture and secondary texture, primary texture occur as roughness and secondary texture occur as waviness. So for primary texture, the ratio of length of roughness to the height of roughness is less than 50 micron. अगर आपके 50 माइक्रोन से कम होती है, that falls under the category of roughness or primary texture. When the width, roughness width to the height of the roughness is greater than 50 micron, then it is called as secondary texture or waviness. So this is the difference between primary texture, roughness, or secondary texture, waviness. So this is a diagram which shows you the nomenclature of a roughness. This is flaw. This is the lay direction. This is the waviness height. This is roughness height. This is a roughness width. This is waviness width. Waviness width, which include number of roughness. This is roughness cutoff length. Roughness cutoff length of width means the sample of the length which is taken for the testing purpose. Okay, so I think today's lecture is over, and we will discuss the other part of this chapter in next lecture. So thank you so much and have a nice day.